The distinction between organic and inorganic compounds didn't begin until the 1780s. Before that, minerals, plants, and animals were considered naturally occurring materials. Around the 1780s, chemists began to classify compounds based on their source. Therefore, it was natural for them to assume that any compounds obtained directly or indirectly from living things like plants or animals as organic compounds. So fats, dyes, tree saps, oils, proteins, vitamins, and cotton were organic compounds, and this study was called organic chemistry. Compounds isolated from non-living sources such as marble, common salt, rocks, and minerals were called inorganic compounds, and the study was called inorganic chemistry. Life was considered precious, and anything obtained from the living was thought to be produced under the influence of some mysterious force existing only in living things. This mysterious force was called the vital force. However, with the synthesis of more and more compounds that required no intervention of living beings, the vital force theory to produce organic compounds was later discarded. With the downfall of the vital force theory, the term organic, which pertained to life, underwent changes. It was observed that all organic compounds, whether synthetic or natural, essentially contain carbon and hydrogen and few other elements like oxygen, nitrogen, sulfur, halogens, and phosphorus. With this new understanding, organic chemistry is now the chemistry of carbon compounds containing hydrogen and one or more additional elements like nitrogen, oxygen, sulfur, phosphorus, and halogens. Inorganic chemistry, on the other hand, is defined as the chemistry of all elements other than carbon and their compounds. This newer definition still has a few exceptions. Compounds of carbon like carbon monoxide, carbon dioxide, carbonic acids, metal carbonyls, metal carbonates, carbides, cyanides all contain carbon, a few hydrogens, oxygen, and other heteroatoms. So one might expect them to be part of organic chemistry. However, they are studied under inorganic chemistry because of their greater resemblance to inorganic compounds. So by bringing in more refinement and specificity, we now call organic compounds to be made of only carbon and hydrogen atoms, collectively called hydrocarbons. All other organic compounds are said to be derived from these hydrocarbons by replacing one or more hydrogen atoms with other atoms or groups. Finally, organic chemistry is now precisely defined as the chemistry of hydrocarbons and their derivatives. This definition removes any previously held focus on classifying compounds based on their origin. This puts spotlight entirely on few elements from the periodic table that are constantly changing our lives and organic chemistry.